High above the mighty Yangtze River, the Three Gorges region cuts a dramatic path through the heart of China. This is a land of towering cliffs, deep valleys, and swirling mists. For centuries, this geography has been both a source of incredible beauty and a massive barrier. Travel here was slow and often dangerous. The winding roads and river routes were the only connection to the outside world. This isolation held back the people and the economy of the region. A new kind of connection was needed, one that could soar above the mountains instead of crawling through them. The dream was bold, to build an airport in a place where eagles dared to fly. The city of Wanzhou, nestled within this rugged landscape, was growing. Its people needed faster access to medical care, education, and business opportunities. The region's unique culture and breathtaking scenery held immense potential for tourism. But getting there was the biggest hurdle. A modern airport would change everything. It would act as a bridge to the rest of China and the world, transforming Wanzhou from a remote outpost into a vibrant hub. This wasn't just about convenience, it was about survival and prosperity. The airport would be a lifeline, delivering progress and hope to millions of people living among the ancient peaks and valleys. Imagine standing on a precipice with the world stretching out below you. That was the vision. An airport not built on a flat plain but carved from the very top of a mountain. This idea seemed impossible to many. The challenges were immense, almost mythical in scale. It would require fighting against gravity, weather, and the solid rock of the earth itself. But the human spirit is a powerful force. When faced with a monumental obstacle, we don't just see the difficulty, we see the opportunity. The need for this airport was so great that it inspired a generation of engineers and workers to take on the impossible. The decision was made. Wanzhou would get its airport. The chosen location was Tawa Mountain, a formidable peak standing guard over the region. It was a bold choice, a declaration of intent. This project would not be about finding the easy way, it would be about creating a way where none existed. It was a testament to the belief that human ingenuity could overcome even the most extreme natural barriers. This airport would be more than just a place for planes to land and take off. It would be a symbol of courage, a monument to what people can achieve when they work together toward a common audacious goal. Building an airport is a complex task, even on flat, stable ground. Now, picture doing it on the narrow spine of a mountain. The primary challenge was brutally simple. There was no flat land. The engineers faced a task of biblical proportions. They had to literally level a mountain peak. The plan was as audacious as it was brilliant. They would slice off the top of Tawa Mountain, a process known as a cut. Then, they would use the millions of tons of excavated rock and earth to fill in the deep surrounding valleys, a process known as a fill. This would create a single, massive, and perfectly flat platform for the runway and terminal. This cut and fill method had been used before, but never on this scale or in such a challenging environment. The numbers were staggering. The plan required moving over 16 million cubic meters of earth and rock. To put that in perspective, it's enough material to fill the Great Pyramid of Giza 6 times over. The highest point of the mountain that needed to be cut down was 160 meters tall, the height of a 50-story skyscraper. The deepest valley that needed to be filled was over 120 meters deep. Creating a stable, compacted foundation out of this rubble was the core engineering puzzle that had to be solved. The risks were enormous. The entire structure would be man-made, a massive artificial plateau perched high in the sky. Any miscalculation could lead to catastrophic failure. The filled-in valleys had to be compacted with incredible precision to prevent the ground from settling later, which could crack the runway and endanger lives. The engineers had to account for everything: the type of rock, the angle of the slopes, the immense pressure of the fill material, and the constant threat of erosion from heavy rainfall. This was not just construction, it was a high-stakes battle against the forces of nature, where every calculation had to be perfect. So the plan was set. It was a blueprint for conquering a mountain. The engineers and planners had done their work on paper, running countless simulations and models. They had mapped every rock formation, calculated every cubic meter of earth, and designed every support structure. Now the theoretical had to become real. The next step was to assemble the army of workers and machines capable of carrying out this monumental task. The world watched as China prepared to move a mountain, turning a wild, untamed peak into a gateway to the modern world. One rock, one truckload, and one explosion at a time. In April 2015, the silence on Tawa Mountain was broken forever. The colossal project began not with a single shovel, but with the arrival of an entire army. It was a force of 2,000 skilled workers, a diverse team of engineers, geologists, machine operators, and laborers. They came from all over the country, drawn to the challenge of a lifetime. These were not just employees, they were pioneers, setting up a camp in a remote, hostile environment. Their new home was a temporary city, perched on the slopes of the very mountain they were there to dismantle. It was a place where teamwork and resilience were the most important tools of all. Alongside the human workforce came the heavy cavalry, a fleet of 800 machines. This was the muscle of the operation. Giant excavators with powerful hydraulic arms, massive bulldozers that could push tons of rock with ease, and a seemingly endless convoy of heavy-duty dump trucks. These machines were the modern-day beasts of burden, tasked with breaking, lifting, and moving the mountain piece by piece. Keeping this mechanical army running was a challenge in itself. A team of mechanics worked around the clock, repairing engines, replacing worn-out parts, and refueling the fleet to ensure the work never stopped. The logistics of supporting this operation were mind-boggling. Everything had to be brought up the steep, winding mountain roads. This included fuel for the machines, explosives for blasting, steel and concrete for construction, and food and water for the entire workforce. A single delay could bring the entire project to a halt. The site operated like a military campaign, with precise scheduling and coordination. Every day, the teams would gather for briefings, reviewing the day's objectives and safety protocols. On a project this dangerous, communication was not just important, it was a matter of life and death. The atmosphere on the mountain was one of intense focus and shared purpose. The workers toiled in shifts, ensuring the project advanced 24 hours a day, 7 days a week. The roar of engines and the rumble of moving earth became the new soundtrack of the mountain. These men and women were united by a common goal: to build something that would last for generations. They were living and working on the edge, pushing the boundaries of what was possible. This was the start of a long and arduous journey, but the determination of the team was as solid as the rock they were about to break. The first step in leveling Tawa Mountain was to break its spirit, and that meant using explosives. Demolition experts were the artists of this phase. They would drill deep holes into the solid rock, following carefully calculated patterns. These patterns were designed to shatter the rock into manageable pieces while controlling the direction of the blast. Every explosion was a carefully choreographed event. A siren would echo across the valleys, signaling everyone to take cover. Then, with a deafening boom and a cloud of dust, a section of the mountain would crumble. It was a spectacle of controlled power, a violent but necessary act of creation. Once the dynamite had done its job, the machines moved in. This was the symphony of steel. Giant excavators, perched precariously on newly created ledges, would claw at the shattered rock. They scooped up massive mouthfuls of earth and stone, their powerful arms swinging with surprising grace. They loaded the debris into a waiting fleet of dump trucks. The trucks, each carrying tons of material, would then navigate a complex network of temporary roads. They drove from the cut zone, the part of the mountain being removed, to the fill zone, the valleys that needed to be built up. This cycle was repeated thousands of times a day. The cut and fill process was a delicate balancing act. As excavators carved away at the peak, they created terraces, like giant steps down the mountainside. This prevented landslides and provided stable platforms for the machinery to work on. As the trucks deposited their loads into the valleys, bulldozers and massive rollers would spread the material in thin layers. Each layer, typically no more than half a meter thick, was then compacted relentlessly. This process was crucial. It squeezed out any air pockets and ensured the new ground was as dense and stable as solid bedrock, ready to support the weight of a jumbo jet. This relentless process continued day and night under the glare of powerful floodlights. The mountain was slowly but surely being reshaped. The peak got lower and the valleys grew higher. The landscape was transformed in a way that would have been unimaginable just a few months earlier. It was a testament to the power of combining raw force with meticulous planning. The workers were not just moving dirt, they were sculpting a new piece of the Earth's surface. They were building the foundation of the airport, one blast, one scoop, and one compacted layer at a time. Working on the top of an exposed mountain meant being at the mercy of the elements. The dangers were constant and came from every direction. One of the biggest enemies was the rock itself. While some of it was soft and easy to move, the teams frequently encountered layers of incredibly hard granite. This tough rock would wear down drill bits and the teeth of excavator buckets at an alarming rate. It slowed progress and tested the limits of the machinery. Blasting this harder rock required more powerful explosives and more precise drilling, adding another layer of risk to an already dangerous job. The terrain was a constant threat. The workers and their heavy machines operated on narrow, temporary ledges with sheer drops just inches away. A moment's inattention or a mechanical failure could have deadly consequences. Safety was the absolute priority. Strict protocols were enforced, and spotters were always on duty, watching for any signs of instability in the rock faces above. The dust was another relentless foe. The constant drilling, blasting, and moving of earth created thick clouds of dust that could choke engines and, more importantly, endanger the health of the workers. Water trucks constantly sprayed the roads and work areas to keep the dust down. Weather was an unpredictable and powerful adversary. The high altitude meant the weather could change in an instant. Blazing sun could give way to sudden, torrential downpours. The heavy rains of the monsoon season were particularly challenging. They turned the work site into a sea of mud, making the steep roads treacherous and halting the compaction process. The water could also weaken the newly filled ground, so engineers had to design sophisticated drainage systems to channel the water away and protect the integrity of the foundation. Working through these conditions required incredible grit and adaptability from everyone on the team. Despite these monumental challenges, the work continued. The spirit of the team was unbreakable. They developed innovative solutions on the fly, like creating new types of drill bits to tackle the hard rock. They reinforced roads and slopes to withstand the rain. They looked out for one another, creating a strong culture of safety and mutual support. Every day they spent on that mountain was a victory against the odds. They were not just building an airport, they were proving that with courage and ingenuity, humans could adapt and thrive in even the most hostile environments. After months of relentless earth-moving, a massive flat plateau finally emerged from the chaos. The mountain peak was gone, and the valleys were filled. It was time to build the runway. This was the most critical part of the entire project. The runway had to be perfectly smooth, incredibly strong, and built to last. The foundation that had been so painstakingly created was now put to the test. The first layer of the runway was made of crushed stone, carefully selected for its size and strength. This layer, several meters thick, was spread across the entire length of the platform, creating a stable base that would distribute the immense weight of landing aircraft. The process of compaction was taken to a new level. Giant, vibrating rollers, some weighing over 50 tons, passed over the crushed stone base again and again. GPS sensors on the rollers ensured that every square meter of the runway received the exact same amount of compaction. This eliminated any potential weak spots. Quality control teams were constantly on site, taking core samples and running tests to measure the density and stability of the foundation. There was zero room for error. The safety of every future flight depended on the perfection of this unseen foundation. Next came the asphalt. Paving a runway at high altitude presents unique challenges. The thinner air and lower temperatures can affect how the asphalt mix cures and bonds. The engineers had to develop a special asphalt formula designed specifically for the conditions on Tawa Mountain. This high-performance mix was resistant to cracking in the cold and deformation in the heat. It was applied in multiple layers by a fleet of specialized paving machines, all moving in perfect coordination to create a seamless, uniform surface. The result was a flawless black ribbon stretching for 2,600 meters across the top of the mountain. Building the runway was a process of precision and patience. It transformed the raw, compacted earth into a sophisticated piece of engineering. Lasers were used to guide the paving machines, ensuring the surface was graded with millimeter accuracy to allow for proper water drainage. Once the final layer of asphalt was down, the runway was painted with its iconic white markings: the center line, the threshold markers, and the touchdown zones. Standing on that finished runway, surrounded by clouds and distant peaks, was an incredible moment. The path to the sky was now paved. A runway is useless without the complex systems that guide aircraft safely to the ground. With the heavy construction complete, a new phase began, installing the airport's technological brain and nervous system. This involved laying miles of underground cables for power and communications. Specialized teams began installing the high-intensity approach lighting system. These powerful lights, mounted on towers leading up to the runway, would cut through the thick fog and heavy rain common in the Three Gorges region. They act as a visual pathway, guiding pilots on their final approach, especially in low visibility conditions. Next came the installation of the Instrument Landing System, or ILS. This is one of the most critical pieces of safety equipment at any airport. The ILS sends out precise radio signals from antennas located at the end of the runway. These signals are picked up by the aircraft's onboard instruments, providing the pilot with exact vertical and horizontal guidance. It allows for safe landings even when the pilot cannot see the runway at all. Calibrating the ILS was a delicate process. A specially equipped flight check aircraft had to make dozens of passes, testing the signals to ensure they were perfectly aligned and accurate. To combat the region's unpredictable weather, a state-of-the-art automated weather station was installed. This system includes a battery of sensors to measure wind speed and direction, temperature, humidity, cloud height, and visibility. This real-time data is crucial for both pilots and air traffic controllers. It allows them to make informed decisions and anticipate potential hazards like wind shear or sudden fog. For an airport perched on a mountain, where weather patterns can be localized and change rapidly, this advanced weather system was not a luxury. It was an absolute necessity for safe operations. These silent guardians, the lights, the navigation aids, and the weather sensors, are the unseen heroes of the airport. They work together to create a safety net of technology that surrounds every flight. Installing these systems on a remote mountaintop presented its own set of challenges, from grounding the equipment against lightning strikes to ensuring a stable power supply. But the teams worked meticulously, knowing that the reliability of their work was paramount. The airport was now more than just a physical structure. It was becoming an intelligent, responsive system ready to handle the demands of modern aviation. While the technical systems were being installed on the airfield, other teams were busy constructing the public face of the airport, the terminal building and the control tower. The terminal was designed to be both functional and beautiful, with large windows offering breathtaking views of the surrounding mountains. It was a bridge between the ground and the sky, a welcoming space for travelers. Inside, crews worked to install baggage handling systems, check-in counters, security screening areas, and passenger lounges. The goal was to create a modern, efficient, and comfortable experience for everyone who would pass through its doors. The air traffic control tower rose beside the terminal, the airport's new watchtower. From this high vantage point, with its 360-degree view, controllers would have an unobstructed line of sight to the entire airfield and its approaches. The tower was equipped with the latest radar displays, communication equipment, and weather monitoring screens. This was the command center, the place where human expertise and technology would merge to orchestrate the safe and orderly flow of air traffic. The controllers who would work here underwent extensive training, familiarizing themselves with the unique geography and procedures of their new mountain domain. With the construction complete, the final phase of rigorous testing and certification began. Every system was checked and double-checked. Fire and rescue teams ran drills, simulating emergency scenarios to test their response times and procedures. The runway surface was tested for friction. The lighting systems were tested at night. The calibration flights for the navigation aids were completed and certified. Every detail, no matter how small, was scrutinized to ensure the airport met the highest international safety standards. The mountain had been tamed, and the machine was ready to be switched on. The culmination of all this effort was the arrival of the first official flight. It was a moment of immense pride and emotion for everyone involved. As the passenger jet gracefully touched down on the runway carved from a mountaintop, it was more than just a landing. It was a victory. The impossible had been made possible. The project had transformed not just a mountain, but an entire region's future. The airport stood as a powerful symbol of human determination, a beacon of progress shining from the top of the world, proving that with teamwork, courage, and a bold vision, there is no mountain too high to climb.